Hi, welcome to the class. Today we'll do Coulomb's law. So Coulomb's law basically tells us about the force which acts between two charged particles. So according to this law statement, according to this law, the force of interaction. Now this word interaction means two charges can interact in two different ways. Two charges can repel each other and two charges can attract each other depending upon the nature of the charges. So if they are like charges, they will repel each other, and if they are unlike charges, they will attract each other. So that is why this force of interaction, and it covers both forces, repulsive, attractive. According to this law, this force of interaction between two charged particles is directly proportional to the product of the charges, to the product of the charges, and inversely proportional to the square of the distance between them. Okay, so basically this is the statement of Coulomb's law. So it basically tells you that suppose you have two charges q1 and then you have q2, and they are separated by a distance r. So there will be a force of interaction between them. Why I am using this word interaction? Because that force could be attractive and that force could be repulsive depending upon the nature of the charges. So this force F, so mind you, this is the magnitude of the force. Okay, so we know that force is a vector quantity. So this vector quantity will have two things with it. One, it will have the magnitude of the force. Another one, it will have the direction of the force. And this magnitude can also be written as F and then F cap. So remember this thing. This we will be using when we are dealing with Coulomb's law in vector form. So right now we are dealing with Coulomb's law only, not with Coulomb's law in vector form. So the magnitude of the force F is directly proportional to the product of the charges, and it is inversely proportional to the square of the distance between these two forces. Right? If I combine these two things, it will be F directly proportional Q1, Q2 and inversely proportional to R square. Now you know that we have to remove this proportionality symbol, and then equality will come along with a constant K. Then it will be Q1, Q2 upon R square. Now what is this K? So this K is a constant of proportionality. K is a constant of proportionality, and its value of K depends on two things. So the value of K depends on two factors. Number one, the value of K depends on system of unit. System of unit. When I say system of unit, I mean it could be CGS system of unit, it could be SI system of unit. And the second, it depends upon the medium between the charged particles. So what is the medium between these two charged particles? The value of K also depends between them, right? Now for K, if I take the system of unit as SI system of unit. So I am taking SI system of unit as I will be dealing with this system of unit only. And then I take the medium between the two charged particles to be air or vacuum. So I am considering the medium between the two charged particles as air or vacuum. In that scenario, the value of K is considered to be 1 upon 4 pi epsilon naught. Now remember, this is a constant and its name is epsilon naught, 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 epsilon naught. So this is a constant, and its value is fixed. I'll tell you its value. So this epsilon naught, it's a constant, and the value of K has become 1 upon 4 pi epsilon naught. So if I substitute it here, so it will be magnitude of force F is equals to 1 upon 4 pi epsilon naught, and then you have Q1 Q2 upon R square. Clear? Now this epsilon naught has a value 8.85 into 10 to the power minus 12 Coulomb square per Newton per meter square. So if you put this value here, multiply it by 4 pi, and then multiply it by 4 pi, you multiply this whole value by 4 pi, so you will get the value of 1 upon 4 pi epsilon naught, and that is equal to 9 into 10 to the power 9 Newton meter square per Coulomb square. So remember this value for calculating the force between the two charged particles. This formula will be used, where the value of 1 upon 4 pi epsilon naught, which is a constant of proportionality, that is K. K depends on two things, system of unit, and it depends upon the medium between the two charged particles. So if we have SI system of unit and medium is air and vacuum, then we take this constant, the value of K as 1 upon 4 pi epsilon naught. This epsilon naught is a constant and its value is this much, and this is this. Okay. Now, an important thing, as we understood that from Coulomb's law, this force depends on two things. I am saying from Coulomb's law, it depends on two things. One, it depends on the magnitude of the charges, and it depends on the distance between them. Okay. But from this value K, I could understand that this K, as this K depends on the medium between the two charged particles. So it means you can see that this force depends on K. The value of K is 1 upon 4 pi epsilon naught. Further, this K, this is the value of K. So this K depends on medium between the two charged particles. So what I say is this, that the force also depends upon the medium between the two charged particles. So as of now, we have considered the medium between two charged particles as to be air or vacuum. But if I replace this medium with something else, then what will be the force? So let me just do that equation here. So this is the force. This is the force when the medium between the two charged particles is air or vacuum. So suppose now we have again two charged particles and there is some other medium. Let it be water, oil, glass, or anything, plastic or anything. If that medium comes, then this force between these two charged particles will be Fm, that is medium, is equals to 1 upon 4 pi epsilon. Now this is epsilon. So this is epsilon naught. Let me tell you the meaning of this also. This is what we call permittivity of free space. So this epsilon naught has the name permittivity of free space, and when I say free space, I mean air and vacuum. So right now I am using Fm is equals to 1 upon 4 pi epsilon. I am not using naught. This naught will come only if you have this free space. Free space means air or vacuum. If naught is not there, then it means there is some other medium other than air or vacuum. Clear? So this I call permittivity of medium other than air and vacuum. Fm is equals to 1 upon 4 pi epsilon q1 q2 upon r square. This will be the value. Now I want to know whether this medium force will change or not if the medium has changed. Means this force has changed its value without changing the magnitude of the charges and without changing the distance. So suppose two charges were kept in air at a distance of 1 meter and the same two charges are now kept in water. Okay, it's the same distance apart. So whether the force will reduce or whether the force will increase, let us figure out. So if I consider this to be equation number 1 and this to be equation number 2, and since I want to know the value of Fm, so I'll do 2 by 1, that is Fm upon F. So guys, if you put the values there, it will be 1 upon 4 pi epsilon q1 q2 upon r square and then 1 upon 4 pi epsilon naught q1 q2 upon r square. Alright, this goes off, 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 this goes off. So this value will go there and I may write Fm upon F is equals to epsilon naught upon epsilon. And this is what we call 1 by k. Now remember, this k is different. This k was a constant of proportionality, but this k is something which we call as dielectric constant. Okay, let me write it there. I'll be writing it at the top. So that k, which is Fm upon F, is equals to epsilon naught upon epsilon is equals to 1 by k, and this k is what we call dielectric constant. Now if you look here, I can write Fm upon F is equals to 1 by k, and if you see that the medium force decreases by 1 by k times of F. Now this dielectric constant will have separate values for separate mediums. Like for water it is 81. For some other medium it will have different value. So it means the medium force decreases by 1 upon k times of the force in air. So it means if two charged particles q1 q2 separated by a distance 1 meter are kept in air and there is a force which acts between them, then if the same charged particles same distance apart are kept in some other medium, in that case, in that medium the force will reduce by a factor of 1 by k, where k will be the dielectric constant for that particular medium. So this is what we need to understand. So that was the Coulomb's law. Tomorrow we will do 2 questions based on this, and then I'll tell you about the Coulomb's law in vector form as well. Thank you.